Ready?
Ready.
All right, fourth grade. Here we go. This is our unit on light reflection, refraction, and opaque and translucent and transparent stuff. Guys, I'm sure you've all seen some of this stuff in action in your day-to-day life. How many of you have ever been in a restaurant and noticed that when you stick a straw into your water, that your straw appears to now all of a sudden be broken or be in two pieces? You may or may not be able to see that through the camera. Well, again, these items will be coming around your classrooms. You guys will see up close and personal, so you'll be able to see that in your classroom. That piece of wood, which is just the same as a straw, that perfectly straight handle on this spoon appears to now be in two different pieces once it enters the water. Well, that's because it is being refracted. And refraction is basically where the light is being bent. These lovely glasses that I and Ms. Smith are wearing are light refracting glasses, and you all are going to get to experience these in just a minute. They actually take the light in this room, and they actually bend it like a prism, and Ms. Smith's going to show you guys one of those in just a second. And they separate out all of the light rays. But that's what's happening here. Is the curvature of this glass and the nature of the water is bending the image of that spoon as it enters the water. So that is being refracted. And Ms. Smith has some more for us on that.
Okay, these look like 3D glasses, but they're actually refraction glasses. So I'm looking at these two light bulbs. One is white and one is green. And the light is being bent. You'll actually get to wear these and see, but it looks like a rainbow. So I'm looking at the white light, and I see the reds, the yellows, greens, and blues. Then I shift to the green light. Now the green light, the light is longer, and I'm still seeing the same colors. So the light is bending through my glasses. And then...
And I'll tell you what, teachers, do this. If you would, take a moment and pause the video, and if y'all would, experience this for just a second. You'll notice that rainbow spectrum is all evenly shared on the white light. But when you shift to that green light, all of a sudden that green section of the rainbow grows. See if you can see that.
And now I have a prism here. Now the prism does the similar thing if you put it up to the light. And this bends light as well. Remember, bending light is refraction. Now I know that you've looked at yourself in the mirror probably today.
Now, is that refraction, Ms. Smith?
That's not refraction.
Oh.
That's called reflection. So the light is bouncing off the surface and back to me. So that's why I see my image with these gray glasses. I'm looking good today. So this is reflection, and this is refraction. Okay, I'm going to take my refraction glasses off for a minute and talk about how light travels through. So there's a term you're going to see is called transparent. Once you look out the window, it's called transparent because light completely travels through the window. So looking at my light right here, you can see all the light is shining out. This light bulb is transparent. It allows all the light through. Just like windows you see everywhere. Now another term you need to know is translucent. Translucent does not let all the light through. This green bulb, the green is absorbing some of the light. So it's called translucent. You can still see the light, but not all of it like this bulb. Now another example of translucent is if you look up by the bathrooms to the skylight. Now we don't see all the sun's rays. We just see some of them. That's called translucent. Now the final term is opaque. This stool is opaque. If I were to shine this light, none of it gets on the other end.
None of that light is shining on my hand from that light bulb because the seat is blocking all of it. So that's opaque. Okay?
And also, you yourself are opaque. No light, if you shine the light at yourself, your friend couldn't see any light behind you because light can't travel through you. So you are opaque as well.
That's an interesting example. I've never heard of that before. That's good. That makes sense. We are. Ladies and gentlemen, the last couple things we've got here is this is one of my Mr. Priestley's fun creations here. I indeed have a remote control car here, but on its wheel and axle, that's right, we've got a wheel, it's on an axle. We're going to be learning about that in the next chapter here, folks. But on our wheel and axle that's attached to this truck, I have placed a color wheel. Now you'll notice I've got red and kind of pink and orange and yellow and green and blue, right? Well, when I squeeze the trigger, all of those colors become kind of white. Now, my truck doesn't spin quite fast enough for it to turn completely white, but indeed, all of the colors have now blended again to become white. And again, this will be coming to your classroom so you guys can see that. So, how does that work? Well, I'm going to tell you it's a little baffling to me as well, but that's okay because you know what? I don't have to understand everything, but I do understand the fact that all of the colors in the rainbow are indeed in the color white. Now, Mr. Vanek has probably talked to you all about that, and that's why our refraction glasses showed that color rainbow, because it is refracting all of those colors back out into the color spectrum, which again is what our prism does as well. Well, I have here a blue square. Well, this blue square looks blue because it is blue. Well, the reason it looks blue is because when the manufacturers were making this little blue square, they soaked this, they saturated this, they filled this with as much blue coloring as possible. So now when the sunlight or these lights in this room come and shine upon this, that entire color spectrum is landing on it, but there's no more room for the blue. So the blue gets bounced back, and my eye now sees only the blue part of the color spectrum. You can probably see the hood of my truck here. It's reflecting red because the plastic that our truck is made out of is full of red. And so when the color spectrum from the lights shine upon it, the red is reflected back to my eye. The red is reflected. It's bounced back.
So you mean all the colors are shining on this truck?
Indeed. All the colors are shining on this truck. They're shining on me and you. They're everything. And so my lab coat is white because it's full of all the colors, even though it's a white coat. I know, you're thinking, Mr. Priestley, that's white. It's clean. Well, but it's reflecting white because it's full of everything. This orange on this bottle is reflecting orange because indeed it is full of the color orange. There's no more room for any more orange, so therefore orange reflects back to my eye. So anyway, and speaking of my spray bottle here, guys, this is going to be coming to your classrooms. Hopefully we'll have some sunny days this week, and if not, we'll get it maybe next week. Maybe I'll be bringing this out there in recess, guys, and kind of just showing anybody and everybody we have a chance. But this bottle will mist water out into the air. Well, water is a fantastic prism, but only in the right conditions. If I walk down to the creek or even my glass of water here, light does not necessarily get refracted. That is a word I have a hard time saying sometimes. It does not always get refracted. Sometimes it just gets reflected, and sometimes the water, if it's dirty or whatever, may just absorb the color. But if you can mist it in a very fine film in the air, as the sunlight travels through it, all those little water particles indeed refract the color, and it ends up making what we call a rainbow.
Oh, like when it rains, when it's sunny.
Exactly.
And you get a rainbow.
Exactly. And today it's been quite rainy outside, and so I have a feeling Ms. Smith and I could step outside right now and look around in the sky, and we, if the sun is out, would indeed see sunlight coming through all that wet, damp air, and therefore it would be getting refracted, and we would see that rainbow up in the sky. And so, light refraction will happen here. Light refraction happens because all of the color is in the colors, right in the white light. It's all about light getting bent. Good deal, guys. Hope you enjoy your reading as well on this, and we will see you soon.